marketing machines. But really, the goal here is to show that things actually can run in a. Our customers basically don't have a solution. You should try all these things, and then they basically end up saying, "Hey, there is no solution." And then we go in and say, no, there's a solution. Here is what it is. And then say, oh, I want to trial it. And then they trial it because they've already trialed everything else. And then they find it's useful. Then they sign with us. That's how we gotta get our customers typically.
We have to rewrite anything in that.
Yes, you have to rewrite it basically since the API, and that's why I say we have a noSql API, which means it's got like 4 API things. So we are modeled on Memcache. So if people who are used to Memcache will find it very easy to change their APIs. They already know what to do. The main reason we changed it is because we don't want to have the overhead of an extra hop to go to the cluster from the client. So we could potentially get every request to the same node in the cluster, and that node in the cluster can answer, for any node. We have that feature, but the point is that will slow everything down. Whereas if you had put a little intelligence on the client, using our own client, then you can be that much faster and better and more stable, which is even more important. Because now you're really load balancing on the client. I can go into more details if people are interested. Yeah.
So does this mean the client will also store the configuration of how many nodes will be there?
It is dynamic because the nodes can keep changing. So there is a protocol through which the client can find out what the status is. Yeah, it's more than a heartbeat. It's almost like an info protocol is what we call it. The heartbeat is within the cluster. The cluster nodes know where each other is. And then the cluster, and so the client can just ask any cluster node, hey, what's the status of the cluster? And the cluster goes like, here it is. Think of it as a multi-level index. So the main thing is I take a data, in this case it's a key value. So I can take a key and say, at the top level, which node is it in? And that node may just be dying right now. So you go there, and node is not there. You go somewhere else. You go to the other node. The other node will find out where this is for you. So you're not going to get a redirect back to the client. So it's very simple on the client. For an API, you just get the data and you get it. But underneath it, there is some intelligence which understands how the load balancing happens across the cluster. And that's kind of unique to what we do. In fact, Citrus Leaf is unique in that.
So every key then of the row will also say which node it got stored to so that the client will reach them.
It's hashing based. So we have functions for all that. And the functions change every time. Functions don't change, but the actual state changes every time a new node adds to the cluster. That node every node in the cluster has a certain set of data it is owner for. It also could be replicating somebody else's data. So it's kind of ownership is distributed. There is no single master, and the distribution is through a hashing algorithm, very sophisticated, hashing algorithm, not invented by us, well understood, public domain stuff. So that's what we do. So I've just listed a bunch of things as to what everybody does. The one thing I haven't listed is, as you notice, there's a bunch of stuff which is not noSql, which means they're SQL. Okay, so that's that. It's not like that's all it is. I mean, for example, Clustrix, Rethink DB, and Volt DB are all SQL based. Everything else is noSQL based. And one of the advantages we have is low TCO, and I can go into that more. But I mean, more importantly, right? I mean, it is. You can see the purpose of this slide is not to show who is better or who is worse, even though that's what we started with. But that's not the point. The point is there are a lot of things out there. So if you're going to go understand what each one does, if it's good enough for you. For example, if all you're interested in is clustering, you don't care about the performance. Cassandra is great. It works. But if you're interested in some kind of real-time usage, Cassandra may not be fast enough for you. Neither would some other React, for example, is written in Erlang, which is kind of very nice and distributed, scales very well, but may not be the fastest thing for you. If you really want to use SQL, you don't want to do something else, then all the SQL things here, none of them are MySQL either. So each one is like, except Rethink DB, I'm sorry. Rethink DB is exactly MySQL SQL, whereas Volt DB has its own version of SQL, slightly different. You all know probably, having worked with SQL databases, everything is slightly different. It's a standard, but but it requires work to make sure that it works. So that's basically it. So that's kind of the end of my presentation, actually. If you have any questions. Yes. Yeah, I mean, we could loosely say the citrus leaf is it does support document APIs. We don't support graph yet. I mean, there are some strategic things we are thinking about right now. I haven't talked about here, mainly because I don't want our competitors to know yet, and that is one reason. The other reason is we also need to think through as to how to take citrus leaf forward from here. In terms of, right, the only hint I will give you is we don't intend to stay in the noSql alone bracket for much longer. More than that, I'm not ready to say at this point. Maybe in 6 months. Once I have people who are actually working on the stuff other than the two of us, we may be actually more confident about saying it. Because right now, anything I say, I may not be able to deliver. That's one of the reasons I don't want to say. Because I know exactly what to do. That's not the point. The point is, will it be done or not, is something which we are still working on. So, but that to me. Okay, I'll throw out a philosophical question. Okay, which just for food for thought, right? I mean, why should a database only have either a NoSQL API or a SQL API? I mean, what's the big deal anyway? Because if you look at how, one of our advisors, is Don Hatterley. He's the guy who used to be called the father of DB2 in IBM. He kind of did DB2 for like 30 years. And DB2 was built with a very fast storage engine called vSAM. Still probably the same thing. And there was a fast API to it, the vSAM API. It was not called noSql. There was no SQL then. And then they built SQL and spent like 10 years optimizing it to make it fast enough. So now we're going back and going like, oh, we need noSQL. Like, why don't you also have SQL? It'll be slower, we know that, but it's not like unusable, is it? Because people use it, right? I mean, and every one of you written applications, in SQL, it works. I mean, I've done it. It works fine. It didn't scale.
You're referring to the SQL language interface to the database.
Yes. Essentially, it's Oracle, MySQL. Yeah, choose your database, and what is it has SQL, it has ACID, it has what I mean all of it. Like the NoSQL says NoSQL and no ACID and all that. Right? I'm saying SQL with the query language, the relational model, whatever. It'll be slow, but is it really? I would not even say it will be slow. I would say it'll be slower than going to a faster API. That's guaranteed, right? I mean, you go through like the API which is seriously fast, straight on it, and I put a layer on top of it and I go through that layer. It will be slower to go through a layer. There's no doubt about it. But is it good enough is the question I think each of you has to answer for yourselves. And which means that is, I think, the big question here left to answer is, can you use the same thing for both? Or should you? Shouldn't you? Or is it not physically? Is there something like the CAP theorem equivalent here saying no, SQL and NoSQL will never mix? That kind of theorem. I don't believe so, but if it is, we'll find out, right? So I think that's kind of an interesting thing for me. Like 5-10 years down the road, I don't expect to have like 20 different databases, one for graph, one for NoSQL, one for SQL. I mean, it doesn't make any sense. It didn't make sense before. It will not make sense later. But why during this period when everybody is experimenting, you have all these different things, which is also